Question 1. A set of scores has the following 5-number summary. What is the range? Now the range is equal to the maximum score minus the minimum score. So this is our maximum score, 9 minus 2, which equals 7, option D. Question 2. What is the value of 3x to the power of 0 plus 1? If we expand this, adding in the multiplication symbol, 3x to the power of 0 is just 3 times x to the power of 0 plus 1. Now, x to the power of 0, anything to the power of 0, is 1. So that's equal to 3 times 1 plus 1, which is equal to 3 plus 1, since 3 times 1 is 3, and that's equal to 4. So it's option D. Question 3. A survey asked the following question. How many brothers do you have? How would the responses be classified? So how many indicates we're counting something. So it's most certainly not categorical data that we're looking for. It's definitely quantitative. And we're talking about counting people. So we're talking about a whole number of people, not fractions of a person. So it certainly cannot be continuous. And so the answer is C, quantitative and discrete, because we're counting whole numbers. Question 4. Which graph best represents the equation y equals x squared minus 2? So we know it's going to be a parabola. X squared is a parabola that looks like this, concave up. So it's most certainly not going to be option B nor option D. Now this minus 2 or this negative 2 indicates a y-intercept. And there's only one graph that has a y-intercept of negative 2, which is option A. So the answer is A. Question 5. The driving distance from Alex's home to his work is 20 kilometers. He drives to and from work 5 times each week. His car uses fuel at the rate of 8 liters per 100 kilometers. How much fuel does he use driving to and from work each week? So each day, Alex is going to be driving 40 kilometers. 20 kilometers to work, 20 kilometers back home. So it's going to be 40 kilometers per day, 5 times each week. So that's going to be 200 kilometers. His car uses fuel at the rate of 8 liters per 100 kilometers. We have 200 kilometers here, so this implies it's going to be 2 times 8 liters, which is 16 liters of fuel for the week. Option A. Question 6. A set of data is displayed in this dot plot. Which of the following best describes this set of data? Symmetrical? Certainly not. So it's not A. Nor is it normally distributed, because we'd expect a bell curve. So it's not D either. So it's either positively skewed, negatively skewed. We look and see where the tail is. The tail is on the negative side or on the left-hand side. So the answer is negatively skewed. Question 7. The diagram shows the positions of towns A, B, and C. Town A is due north of town B, and angle CAB is equal to 34 degrees. What is the bearing of town C from town A? Here's our town C, here's our town A. The bearing of town C from town A is measured from true north clockwise. So from north to south is 180 degrees, plus 34 is 214 degrees. Option C. Question 8. A nanny charges $15 per hour or part thereof for looking after a child. What does the nanny charge for looking after a child from 8 a.m. until 3:20 p.m. on a particular day? So what we're going to do first of all, just for you to help visualize what's going on here, we're going to work out the number of hours from 8 a.m. until 12 p.m. and that's 4 hours. And then from 12 p.m. until 3:20 p.m. that's 3 hours and 20 minutes. Now we need this in fraction form in fact. So total time is 7 hours and 20 minutes. Now 20 minutes as a fraction of an hour is in fact 1/3. In fact, for you just to quickly see that, 20 divided by 60 is 1/3. So this is equal to 7 1/3 of an hour. We're going to take that, multiply it by 15. Okay. So 7 1/3. Multiply that by 15 and we get $110. Now another way to quickly do this is we can enter in 7 hours and 20 minutes into the calculator using the degrees, minutes, seconds button. So I'll just lighten that for you. 7 hours, 20 minutes, multiplied by 15, and we get $110. Question 9. An experiment has 3 distinct outcomes, A, B, and C. Outcome A occurs 50% of the time. Outcome B occurs 23% of the time. What is the expected number of times outcome C would occur if the experiment is conducted 500 times? The first thing is let's work out the percentage of time that outcome C would occur, or what percentage of the time outcome C would occur. That's going to be 100% minus 50% for outcome A and minus 23% for outcome B. So in fact, 100 minus 50 is 50, 50 minus 23 is 27% of the time. Okay, by all means feel free to use your calculator. Now, 27% of 500 gives you 135. So we expect outcome C to occur 135 times out of 500. Question 10. A biologist caught a random sample of 56 parrots in a national park. She tagged them and then released them. She later returned to the park and caught a random sample of 47 parrots. In this sample, 29 had been tagged. Using the capture-recapture technique, what is the estimated number of parrots in the park? Let's have a look at the recapture first. We have 47 parrots captured, of which 29 have been tagged. So we're going to write this as the ratio 29 to 47. In the original capture, 56 parrots were tagged, so that corresponds to the 29, to a total number of parrots in the forest, which we don't know, which we're going to use the pronumeral x to represent. We're going to write this now as a fraction. So 47 over 29 is equal to x over 56. So it's the second term over the first term in each respective ratio. Let's make x the subject of the formula. So we're going to multiply the fraction 47 on 29 by 56. So 56 multiplied by 47 over 29, and that's equal to x. Okay, so 56 multiplied by 47 over 29, and just press the SD button. We get 90.758. And that's going to be closest to 91. So it's going to be option C. Question 11. A set of data is summarized in this frequency distribution table. Which of the following is true about the data? So the first thing we need to work out is the mode. And the mode is the score that has the highest frequency, which is going to be 7. So there's our mode. So it clearly cannot be option C and it cannot be option D. Now to work out the median, you can either add a cumulative frequency column, but there's probably under pressure, there's a reasonable chance that you may get that wrong, or you could just quickly use stat mode, if you're fairly quick at that, And I'm just going to enter that in quickly. 3, 4, 5, 6, 7, 8. And then just enter in the frequency. So 1, 2, 6, 7, 9, and 5. Shift 1, min max 5, median number 4, answer 6. So it's going to be option B. Question 12. The diagram shows a triangle with side lengths 8 meters, 9 meters, and 10 meters. What is the value of theta marked on the diagram to the nearest degree? This is an application of the cosine rule for unknown angles. I'm going to label the triangle first with the unknown angle as angle A, uppercase A. Then I'll label the other two vertices, and I'm going to label the sides. Okay? They need to be opposite the vertices with the same letter, just a lowercase version. So cos of A is equal to 8 squared plus 9 squared minus 10 squared over 2bc. So 2 times 8 times 9. We need the A on its own, so that's going to be inverse cos of 8 squared plus 9 squared minus 10 squared over 2 times 8 times 9. Entering in that into your calculator. Okay. So I'll just brighten it up a little bit there. Shift cos and 8 squared plus 9 squared minus 10 squared over 2 times 8 times 9. And we get 71.79, and the answer that's closest to that is option D, 72 degrees. Question 13. A rectangular pyramid has base side lengths 3x and 4x. The perpendicular height of the pyramid is 2x. All measurements are in meters. What is the volume of the pyramid in cubic meters? Now the volume of the pyramid is given by the formula. Volume is equal to area of the base multiplied by the height divided by 3. Now the area of the base is 4x times 3x. And the height is 2x. And all of that's being divided by 3. Now, to make life a little bit easier, we can cancel that 3 with this 3 there. And we end up with 4x times x times 2x. That's going to be 8x to the power of 3. So it's going to be option A. Question 14. To determine the retail price of an item, a shop owner increases its cost price by 30%. In a sale, the retail price is reduced by 30% to give the sale price. How does the sale price compare to the cost price? Now, we don't know what the price of the item is, so let's just say, for argument's sake, it's $100. So $100, we're going to increase that by 30%, which is the same as multiplying it by 130%. And then we're going to reduce that increased price by 30%. So we're going to multiply that by 70%. And let's see now what the sale price is compared to the original price of $100. So 100 multiplied by 130% multiplied by 70%, and we get $91. So the sale price is less than the cost price, option A. Question 15. Sam is the driver at fault in a car accident. Which of the following is covered by Sam's compulsory third-party CTP insurance? CTP covers injury to the other driver. So this is just about knowing what CTP covers. Question 16. Which expression is equivalent to k squared over 10 divided by 5 over k? First thing we do, change the division into a multiplication, and we invert the second fraction. Then we just multiply the numerators together and then multiply the denominators together. So we end up with k cubed over 50. K cubed over 50, option D. Question 17. The area chart shows the number of students involved in tennis or cricket at a school over a number of years. In which year was the number of students involved in tennis equal to the number of students involved in cricket? So let's have a look at 2013. We have 40 students involved in cricket, but only 10 involved in tennis. So what we're looking for is the distance from the x-axis to the first line equal to the distance from the first line to the second line. And in fact, that's going to happen at 2015. We have 30 students here for cricket, and then counting from the line that represents cricket up to the line that represents tennis, there's another 30 students there. So the answer is option C, 2015. Question 18. The length of a window is measured as 2.4 meters. Which calculation will give the percentage error for this measurement? In order to calculate the percentage error, we need the absolute error, which is equal to plus or minus half the precision. The precision is the smallest unit that we could measure based on this reading, which is in steps of 0.1 meters. So let's write this down. Precision is equal to 0.1 meters. The absolute error is equal to plus or minus half of 0.1, which is going to be 0.05 meters. The percentage error is equal to the absolute error, which is 0.05, over the original measurement, which is 2.4 meters, and then to convert it into a percentage, we multiply it by 100. So not going to be option C, not going to be option D, can't be option B because we've got to multiply it by 100. The only option we have left is option A. Question 19. The table shows the compounded values of $1 at different interest rates over different periods. Amy hopes to have $21,000 in 2 years to buy a car. She opens an account today which pays interest of 4% per annum, compounded quarterly. Using the table, which expression calculates the minimum single sum that Amy needs to invest today to ensure she reaches her savings goal? So first of all, we have 4% per annum compounded quarterly, which means it's 1% per quarter. So we need this column here. Now, the other thing as well is she's going to be saving over a 2-year period. Compounded quarterly, that's 8 compounding periods altogether. So it's going to be this row here. So the number involved from the table is 1.0829. So that rules out option A and option B. Now, because we're looking at the future value of $21,000, we want to work out what present value we need to invest or need to save. It's going to be a division because we're starting with the end result, not starting with the present value. So it's going to be option D. During a year, the maximum temperature each day was recorded. The results are shown in the table. From the days with a maximum temperature less than 25 degrees Celsius, one day is selected at random. What is the probability to the nearest percentage that the selected day occurred during winter? So we're only interested in the days where the maximum temperature is less than 25 degrees Celsius. So in the table, we're only interested in this column. So the total number of days where the temperature is less than 25 degrees Celsius is 223, of which the number of days in winter where the maximum temperature is less than 25 degrees is 71 days. We'll multiply that by 100 to convert it into a percentage. So 71 over 223, multiply that by 100, press the SD button, and we get 31.83. So of the 4 options, the one that's closest to that is option C. Question 21. David earns a gross income of $890 per week. Each week, 25% of this income is deducted in taxation. David budgets to save 20% of his net income. how much does he budget to save each week? So the first thing we need to do is we need to take away 25% in taxation. So net income. The easiest way to work that out is to take 890 and we multiply that by 75% because that's what's left after 25% is taken out. So 890 multiplied by 75%, and we get $667.50. Now we need to work out how much David budgets to save. So the savings is equal to $667.50. We're going to multiply that by 20%. Okay, so multiply that by 20%, and we get $133.50. That's going to be option B. Question 22. A shape consisting of a quadrant and a right-angled triangle is shown. What is the perimeter of this shape correct to 1 decimal place? The first thing we need to do is to find the radius of this quadrant, which is a quarter circle. In order to do so, we need to use the right-angled triangle and we need to use Pythagoras' theorem. So let's call that x. So x is equal to the square root of 10 squared minus 6 squared. Square root of 10 squared minus 6 squared, and we get 8. Okay, so that's going to be, actually we'll put it here, 8. This is also 8. So the arc length of this quadrant is equal to 2 pi r, which is a full circle, but then we need to divide that by 4 or multiply it by a quarter to get the arc length for the quadrant. So that's going to be 2 pi times 8 divided by 4, and we get 12.566. Let's add that here, 12.566. Okay, we'll round it later. Now to work out the perimeter, we have 8 plus 6 plus 10 plus 12.566, and we end up with 36.566, which is 36.6. Option B. Question 23. A set of data is normally distributed with a mean of 48 and a standard deviation of 3. Approximately what percentage of the scores lies between 39 and 45? So let's draw a number line to represent these values. Okay, so there's the mean. I'm going to put the mean up here. So that's the mean of 48. Let's subtract one lot of standard deviation, and that'll give us 45. Now this happens to be a z-score of -1. Now if we go down another standard deviation, we get 42. That's a z-score of -2. If we go down another standard deviation, which gives us a score of 39, its z-score is -3. So what we want is we want the percentage of scores that lie between these two values, between a z-score of -1 and a z-score of -3. Now hopefully you would have prepared one of these already, okay? And I do have a video on preparing one of these, okay? Adding in these percentages on top of the normal distribution. So we want these two percentages there, 2.35 plus 13.5. So that's going to be 15.85%, which is option A. Question 25. Which of the following expresses V as the subject of K equals half mv squared? So I'm going to start off by writing the equation a little bit differently. So mv squared, that's mv squared on 2, which is the same as half mv squared. Let's multiply both sides by 2, move the 2 over, it becomes 2k is equal to mv squared. Now we divide both sides by m, and it's the same as moving m under the 2k. So 2k over m is equal to v squared. Lastly, we take the square root of both sides. And because we're taking the square root of both sides and we're going to make v the subject, it becomes plus or minus. So plus or minus 2k over m is equal to v. So can't be option D, can't be option B. Plus or minus 2k over m looks like option A. Question 1. This diagram shows the possible paths in kilometres for laying gas pipes between various locations. Gas is to be supplied from one location. Any one of the locations can be the source of the supply. What is the minimum total length of the pipes required to provide gas to all the locations? So this is an application of minimum spanning trees where we could use either Kruskal's algorithm or Prim's algorithm. So we're just going to use Kruskal's because it's probably the easiest algorithm to apply. And we just go from the lowest weight edge to the highest weight edge without forming any cycles. So we'll choose this edge first. Okay, so Somerville to Parkview. We can't choose this edge here of weight 7 because that'll form a cycle. So the next edge to choose would be this one here. So as we choose each edge, we're just going to write the weight of each of the edges chosen. So that's 5 plus 8. Okay, so that's connected those three together. Okay, so the next edge to choose, we could choose 10. Okay, so that connects Somerville to Beachview. Okay, so we've got one more town to connect up. So we could either choose the 12 or we can choose the 11. So I think the obvious choice here is the 11. Okay. So 13 plus 10, 23. 23 plus 11 is 34. So the answer is 34 kilometers. Question 2. A computer application was used to draw the graphs of the equations x plus y equals 5 and x minus y equals 5. Part of the screen is shown. Which row of the table correctly matches the equations with the lines drawn and identifies the solution when the equations are solved simultaneously? So here are our 4 options. First of all, let's go to the graph and let's look at the point of intersection. This is the coordinate 5, 0. In other words, x equals 5, y equals 0. And there's 2 options here with that coordinate, x equals 5, y equals 0. So it could be this option there, or so option A, or it could be option C. So it cannot be option B, cannot be option D. Now let's go to the original equations. So x plus y equals 5, x minus y equals 5. We need to rearrange one of these into the form y equals mx plus c. So this is the gradient intercept form. Let's have a look at the first equation. Leaving y where it is and leaving the 5 where it is, this x can move over and becomes negative x. Because the x is negative, this implies it's a negative gradient, it's a downhill. So this is line 1, x plus y equals 5. Line 1, x plus y equals 5. It must be option A. Question 3. A survey was conducted into the number of hours worked by casual staff in the hospitality industry. It was found that the weekly average was 18 hours with a standard deviation of 2.5 hours, and that the number of hours worked was normally distributed. Based on the survey, what is the percentage of casual staff working fewer than 23 hours in a week? So the step 1, we need to work out the z-score for 23 hours. So z is equal to 23 minus 18, which is the mean, over 2.5. So entering in that in the calculator, so 23 minus 18 over 2.5, we have a z-score of 2. Okay, so if you use the normal curve or the bell curve on the formula sheet or the reference sheet, okay, this is our z-scores, so that's 2, 1, -1, -2, okay. So Z-score there. Okay. We know that the tail above Z-score of 2 is in fact 2.5%. But we want fewer than 23 hours. In other words, we want the area under the curve, or the percentage under the curve, that's less than 2, not greater than 2. So this is going to be 100 minus 2.5%, which is equal to 97.5%, which is option D. Question 4. What amount must be invested now at 4% per annum, compounded quarterly, so that in 5 years it will have grown to $60,000? So this is our future value. Take note, it's compounded quarterly. Okay, so that means that the interest rate is 1% per quarter, which is a quarter of 4%. And also means that the number of compounding periods is 5 years times the number of compounding periods per year. Compounded quarterly means 4 times a year. So that's going to be 20. So our formula is going to be 60,000. Our future value is equal to the present value multiplied by 1 plus 1% to the power of 20. So now we need to solve for PV, present value. So that's easy enough to do. 60,000 divided by this entire expression in brackets, okay, which is the 1 plus 1% to the power of 20, and that'll give us our PV. Okay. So 60,000 divided by 1 plus 1% to the power of 20, and we get 49172.66. And we're going to round it to the nearest dollar, so that's 49173 would be our closest answer, option C. Question 5. The table shows the average energy used in kilojoules per kilogram of body mass by a person walking for 30 minutes at different speeds. Sam, who weighs 65 kilograms, drinks a regular cappuccino made with full cream milk. It contains 73 kilocalories. For approximately how long must Sam walk at 3 kilometers per hour to burn off the energy contained in the cappuccino, where 1 kilocalorie is equal to 4.184 kilojoules? So first thing we need to do is to work out how many kilojoules does Sam burn when he walks at 3 kilometers per hour. So let's go back to the table. We don't need this row here at all. We're only interested in this row here. And we know that Sam weighs 65 kilograms. So what we're going to do is multiply 65 by the kilojoules per kilogram. So that gives us 359.45 kilojoules. 0.45 kilojoules. And that's for 30 minutes of walking. So Sam has a 73 kilocalorie cappuccino. So in kilojoules, so we're going to convert everything to the same unit of measure. 73 multiplied by 4.184, we get 305.432. kilojoules. So clearly, Sam needs to walk for less than 30 minutes, so it can't be option C and it can't be option D. And if we take this number here, okay, so we're trying to work out what fraction of 30 minutes does Sam have to walk for. I'm not even going to bother with the decimal, just 305 divided by 359, 0.849, multiply that by 30 minutes, and we get a number that's very close to 25 minutes. So the answer is option B, around 25 minutes. Question 6. The network diagram represents a system of roads connecting a shopping centre to the on-ramp of a freeway. Traffic moves via several routes. For example, there are 2 routes from the shopping centre to P and 1 route from T to U. The number on the edge of each road indicates the number of vehicles that can travel on it per hour. So for example, 70, 85, it's the number of vehicles per hour there. At present, the capacity of the network from the shopping center to the on-ramp is not maximized. Which additional road or roads would increase the network capacity to its maximum? Maximum network capacity means one thing. It means every one of these nodes, okay, or every one of these vertices is perfectly balanced. That means the capacity in must equal the capacity out. Now, if vertex P, we have 70 plus 85 is 155. So there's 155 in there at P. 65 plus 90 is the outflow of P. That's also 155. So vertex P is perfectly balanced. So in fact, option A is incorrect. Let's have a look at some other vertices. So let's have a look at vertex Q. We have 65 in, 45 out. So vertex Q is unbalanced. So there's clearly a deficiency there or an inefficiency. We need an extra 20 cars per hour coming out of Q to maximize vertex Q. Let's have a look at vertex R. Okay, we have 90 plus 45 in, so that's 135. And we have 47 plus 50 plus 38. If you just want to quickly add that up, 47 plus 50 plus 38, we get 135 as well. So vertex R is balanced. So anything with R is not an option. So option C is gone as well. So let's have a look at vertex S, 50 in, 30 out. So it'd be great if we can have an extra 20 cars coming out of S, and that would maximize vertex S. Now, vertex U has 115 coming in, 63 plus 92 coming out. So 60 plus 90 is 150, plus 3 plus 2, there's 155 coming out of U, but only 115 coming into U. Now, it would be nice if we had 40 cars coming into vertex U, and that would maximize vertex U. So the answer has to have U in it, which is option D, because that's the only one that has vertex U in it. That obviously is not one of the options that we've already crossed off. Question 26A. Jeremy rolled a biased six-sided die a number of times. He recorded the results in a table. What is the relative frequency of rolling a 3? Now, the first thing we need to do is to add up the frequency column to find out how many trials were conducted. So 23 plus 19 plus 48 plus 20 plus 21 plus 19. So we get 150 trials. So the relative frequency is equal to, out of 150, rolling a 3 is 48. And if you wanted to, you could simplify the fraction. And why don't we? 8 on 25. Question 26B. Clark's formula, given below, is used to determine the dosage of medicine for children. For a particular medicine, the adult dosage is 325 milligrams and the correct dosage for a specific child is 90 milligrams. How much does the child weigh to the nearest kilogram? So we know the dosage for this child is 90, so I'm just going to write the numbers above each of the variables. We know that the adult dosage is 325, so I'm just going to write it there. We need to solve for weight in kilograms. Let's call it X. Okay, so substituting in the values, we have 90 is equal to X multiplied by 325, and all that is being divided by 70. Let's move the 70 over by multiplication. So the opposite of division is multiplication. 90 times 70 is equal to X multiplied by 325. Now let's move the 325 over. We have 90 multiplied by 70. I'm going to put that in brackets. Divide that by 325 is equal to X. So 90 multiplied by 70. Divide that by 325. And we get x is equal to 19.38. But we need the answer to the nearest kilogram, so therefore x is equal to 19 kilograms. Question 26C. Ali made monthly deposits of $100 into an annuity for 5 years. Calculate the total amount Ali deposited into the annuity over this period. So they're monthly deposits, which means that there's 12 months in a year, over 5 years, and each deposit is $100. So it's $100 per month, times 12 months, times 5 years, and that gives us the total amount of money. So 100 times 12 times 5 gives us $6,000. Question 26D. The graph displays the mean monthly rainfall in Sydney and Perth. So part 1, for how many months is the mean monthly rainfall higher in Perth than in Sydney? So we'll look for the bar that represents Perth. We'll look for the months where the bar that represents Perth is higher than the bar that represents Sydney. So certainly not January, February, March, April, May, June. In July, Perth's higher, August, and also September. So we have 3 months. So for part 2, for which of the two cities is the standard deviation of the mean monthly rainfall smaller? Justify your answer without calculations. So a small standard deviation implies small variation. Now if we look at Sydney, we can see that the bars for Sydney don't vary all that much compared to the bars for Perth. So there's definitely far more variation between the months with least rainfall to the months with most rainfall. So the answer for this one is Sydney. And we would say that the variation in rainfall between the lowest and highest levels is smaller than Perth's. Question 26E. A cumulative frequency table for a dataset is shown. What is the interquartile range of this dataset? So this solution is different to the solution in the NESA marking guide. So just an alternative way of solving or entering this problem. What I'm going to do is I'm going to create a frequency column and convert the cumulative frequencies into the frequencies for each score. Score 1 occurs 5 times. The score 2 occurs 9 minus 5 times, which is 4 times. The score 3 occurs 16 minus 9 times, which occurs 7 times. The score 4 occurs 20 minus 16 times, which occurs 4 times. The score 5 occurs 34 minus 20 times, which is 14. And the score 6 occurs 42 minus 34 times, which is 8. Now what we're going to do is just use the stat mode on the calculator to just enter in the frequency table. So 1, 2, 3, 4, 5, 6. And then entering in the frequencies 5, 4, 7, 4, 14, and 8. Now shift 1 will get it into the min-max menu. Q3, 5. And then we'll work out Q1, min-max, Q1, 3. And we get 3. Therefore, the interquartile range is equal to 5 minus 3, which equals to 2. (26G). A field diagram of a block of land has been drawn to scale. The shaded region ABFG is covered in grass. The actual length of AG is 24 meters. Part 1. Show that the scale of the diagram is 1 centimeter equals 3 meters. So the first thing that we need to do is to measure the length of AG on the diagram, and it happens to be 8 centimeters. So let's just write that down. So is equal to 8 centimeters. Right. Hence, the scale is 8 centimeters is equal to 24 meters in reality. Now, dividing both sides by 8, is 1 centimeter equals 3 meters. Let's have a look at part 2. So part 2 is on a new page. So question 26, part 2. How much fertilizer would be needed to fertilize the grassed area ABFG at the rate of 26.5 grams per square meter? So what we'll need to do is to calculate the area of this shape. And this shape's in fact a trapezium, or you could calculate it as a rectangle plus a triangle. So what we'll need to do is to use our scale. Okay, so this is the scale. 1 centimeter is equal to 3 meters. Okay. So what we do is that we measure the number of centimeters of each of the edges, okay, each of these intervals, and then multiply by 3, and that's the answer, or the length of that interval in meters. So that's 3 centimeters there. Multiplying it by 3, this is going to be 9 meters. Okay. AE. Actually, we'll treat it as a trapezium. Okay. So we know that's 8 centimeters already. We know that's 24. So I'm just going to write 24 there. Okay. We'll need BF, and that's 6 centimeters. Multiplying that by 3, we get 18. And that's all. So let's work out the area now. So area of ABFG is equal to, now I'll turn this around so you can see that, the average or the mean of the parallel sides of this trapezium. So it's 18 plus 24 on 2. Multiplied by the distance between the parallel sides, or the height, which is 9 meters. Okay, so just entering that in. 18 plus 24 over 2 multiplied by 9, and we get 189 square meters. So how much fertilizer then would be needed? So is equal to 189 square meters multiplied by the rate, which is 26.5 grams per square meter. And we get 5008.5 grams. Or that would be 5.0085 kilograms, but this answer here would be sufficient. Question 26H. A car is purchased for $23,900. The value of the car is depreciated by 11.5% each year using the declining balance method. What is the value of the car after 3 years? So this is the formula. Salvage value is equal to initial value multiplied by 1 minus the depreciation rate as a percentage to the power of n, which is the number of years. So the initial value is 23,900 multiplied by 1 minus the rate as a percentage. So I'm going to write it as 11.5% to the power of 3, because that's over 3 years. So entering in that expression in the calculator, 23,900 outside of 1 minus 11.5%. Make sure you type in the percentage symbol there. And to the power of 3, so I'm going to press the execute button there. And we get $16,566.38. Correct to the nearest cent. Question 27C. A shade shelter is to be constructed in the shape of half a cylinder with open ends. The diameter is 3.8 meters and the length is 10 meters. The curved roof is to be made of plastic sheeting. What area of plastic sheeting is required to the nearest square meter? Now, just imagine the shape. Okay, if I was to take this piece of paper and roll it into a half cylinder, okay, you're talking about something that looks like this. Now, if you were to flatten this piece of paper back out, you get a rectangle shape. Okay. Now, the width of this rectangle is in fact equal to half the circumference of this circle. So the area of this rectangle is equal to half the circumference of the circle multiplied by the length. So what's half the circumference of the circle? It's going to be 2 pi r multiplied by the length, which happens to be 10 meters. Now, we're given the diameter of this circle is 3.8 meters. We don't work with the diameter, we work with the radius. Times, now that's going to be 3.8 over 2. So that gives us the radius of the circle, and then we're going to multiply that by the length. Now, let's enter that all in. And we get 59.69 square meters, and then rounded to the nearest square meter, that's going to be 60 square meters. Question 27D. The graph shows the cost, P dollars, charged by 2 companies for the hire of a minibus for X hours. Both companies charge $360 for the hire of a minibus for 3 hours. So part 1, what is the hourly rate charged by company A? Now, just before I answer this question, I've actually changed the pronumerals to make them a little bit more compliant with the current syllabus. So the old syllabus, or the previous syllabus, will use y equals mx plus b, but we're really meant to be using y equals mx plus c. So that's why these pronumerals here have been changed. Let's get back to part 1. What is the hourly rate charged by company A? Now notice the line for company A starts off at the origin, so it's $0 for 0 hours. There's no booking fee or anything like that. For 3 hours, it costs $360. So hourly rate is really equal to 360, divide that by 3, and that's equal to $120 per hour. Now, part 2, company B charges an initial booking fee of $75. Write a formula in the form P equals mx plus c for the cost of hiring a minibus from company B for X hours. So if I look at the graph of company B, we can see that there's clearly a y-intercept there. In fact, that's what represents the booking fee. So we could write it this way, and we know that it's $360 for 3 hours. So let's just substitute in what we know into this equation. 360 is equal to M, we don't know what the gradient is, which represents the hourly rate, multiplied by 3 hours, plus 75, which is the initial booking fee. Let's rearrange this formula. Okay, so 360 minus 75 is equal to M times 3. So M is equal to 360 minus 75. Then we're going to divide that by 3. So M, the gradient, which represents the hourly rate, okay, is equal to, so 360 minus 75 divided by 3, and we get 95, which is in fact the hourly rate, $95 per hour. Therefore, the equation is P is equal to 95x plus 75, which is the initial booking fee. So part 3, a minibus is hired for 5 hours from company B. Calculate how much cheaper this is than hiring from company A. Okay, so there's company B. Beyond 3 hours, we can see that company B is going to be cheaper. So let's just work out the cost for 5 hours for both companies and then find the difference. Okay, so the cost, so let's work out company A first. Okay, it's going to be 5 hours multiplied by $120 per hour. Okay, and that's going to be equal to 5 times 120, $600 for the 5 hours. Now let's work out company B. Okay, and we can use our equation that we used from part 2. Okay, so we'll definitely need that. So 95 multiplied by 5 hours plus the booking fee of $75. Okay, so 95 multiplied by 5 plus 75, and we get $550. Okay, so 600 minus 550 is equal to $50. Therefore, company B is cheaper by $50. Question 27E. Joanna sits a physics test and a biology test. Part 1. Joanna's mark in the physics test is 70. The mean mark for this test is 58 and the standard deviation is 8. Calculate the Z-score for Joanna's mark in this test. So Z-score is equal to her score minus the mean over the standard deviation. So that's going to be equal to her mark, which is 70, minus the mean, which is 58, over 8. And entering in that expression in the calculator to evaluate it, over 8, and we get 3 on 2, which is 1.5. So, part 2. In the biology test, the mean mark is 64 and the standard deviation is 10. Joanna's Z-score is the same in both the physics test and the biology test. What is her mark in the biology test? So now we're going to reverse this formula and we're going to solve for X. So she had the same Z-score. So 1.5 is equal to whatever her mark was in the biology test minus the mean of that biology test, which is 64, over the standard deviation of that biology test, which is 10. Now we're going to rearrange the formula. We're going to take the 10 here. We're going to multiply the 1.5 times 10. So 1.5 times 10 is equal to X minus 64. This minus 64, we're going to move that over by adding 64 to the other side. So 1.5 times 10 plus 64 is equal to x, and x is her raw mark in biology. Therefore, x equals, so 1.5 multiplied by 10 plus 64 is 79. Okay. So her biology mark is 79. Question 28b. Solve the equation 2x over 5 plus 1 is equal to 3x plus 1 all over 2, leaving your answer as a fraction. So the first thing to notice is we have a combination of fractions and whole numbers, and the fractions have different denominators. So before we can equate fractions and whole numbers together, why don't we express them all with the common denominator first? Then we can go from there and eliminate that denominator. So we end up with hopefully just whole numbers and no fractions that we're dealing with. So we can use a common denominator of 10 because 5 can divide 10, 1 can divide 10, and 2 can also divide 10. So 2x over 5, okay, we're going to express this using an equivalent fraction. So 2x over 5 on a denominator of 10. So we're going to multiply this first fraction by 2 over 2. 1 can be expressed with the denominator of 10, that's just 10 over 10, so that's going to be multiplied by 10. And 3x plus 1 all over 2, we're going to express this with a denominator of 10. We're going to multiply this entire fraction by 5 over 5. So 2x over 5 is 4x over 10 plus the number 1 is really just 10 over 10. So multiplying that by 10 on 10, you get 10 over 10, which is just 1, is equal to 3x plus 1 over 2. So that's the same as 5 outside of 3x plus 1 all over 10. So all three terms now are expressed with a common denominator of 10. So we can now eliminate that denominator altogether. So what this allows us to do is to write it this way. 4x plus 10 is equal to 5 outside of 3x plus 1. Notice, no denominator, gone. That's the beauty of common denominators. Once you have a common denominator, you can just eliminate them. So, moving on. Let's expand this bracket. So the next line will be 4x plus 10 is equal to 5 times 3x, that's 15x. 5 times 1 is 5. Now this looks like a regular two-step equation. Let's collect the like terms, and actually let's move the x's to sort of to one side, to the left, and move the constants, these numbers or constants, over to the right-hand side. So 4x, the 15x moves over, it becomes 4x minus 15x. The plus 5 is on the right, on the correct side, on the right side there. And it is on the right side, so pun intended. 5 minus 10. Okay, so moving the plus 10 over, it becomes minus 10. Now 4x minus 15x is negative 11x. 5 minus 10 is negative 5. Therefore, x is equal to negative 5 over negative 11. And a negative divided by a negative just makes it positive. So therefore, x is equal to 5 over 11. Now, if you have a spare moment, you want to check and make sure that this actually works. So I might just do this on this side here. So this is a check. Okay, let's work out the value of the left-hand side. Okay, so what we'll do is we'll put in our value that we just came up with. So 5 over 11. Shift, store. Now x just above the bracket there. Okay, so now we've put that in the memory location x. Now let's type in, using the alpha key, the left hand side. So 2 alpha x over 5 plus 1, and we get 13 on 11. Let's check the right hand side. Okay, so 3 alpha x plus 1 over 2, and we get 13 on 11. Hopefully, if you've done that correctly, we know then that this is the correct answer. So we're happy with that. Question 28C. Every day, a 1200 watt microwave oven is used for 45 minutes at 40% power. Electricity is charged at 25 cents per kilowatt hours. What is the cost of running this microwave oven for 180 days? So I think the first thing we need to do is to work out the power consumption first, then we'll work out the energy consumption in kilowatt hours, then we'll work out the cost per day, and then we'll multiply that by 180 days to get total cost for those 180 days. So power is equal to 1200 watts. Now we need this in kilowatts. So we need to divide this by 1000 to convert that into kilowatts, because all calculations must be in kilowatts to work out the cost. And it's also running at 40% power, so we're going to multiply this by 40% as well. So working that out, 1200 watts, converting that into kilowatts by dividing it by 1000, and then multiplying it by 40% because we're running the microwave at 40% power. And we have 0.48 kilowatts. Now let's work out the energy used. So energy is a product, okay? So it's the product of power and time, but the time must be in hours. So energy used is equal to the power, so 0.48 kilowatts. And we're going to multiply that by the number of hours used per day. And that's going to be 45 minutes. So converting 45 minutes into hours, we need to divide that by 60. Okay, and we get 0.48 multiplied by 45 over 60. And we get 0.36 kilowatt hours. So energy is in kilowatt hours, 0.36 kilowatt hours, and that's per day. So let's just clarify this to make sure that we remember to multiply this by 180 days in the end. Okay, so let's work out the cost per day. Okay, is equal to 0.36 kilowatt hours. We're going to multiply that by the cost per kilowatt hour, so it's $0.25. Okay, so 0.36 multiplied by 0.25, and we get 9 cents. That's per day. And finally, the cost for 180 days. Okay, is equal to the cost per day, 0.09. Multiplying that by 180 days. Okay, so 0.09 multiplied by 180 days, and we get $16.20. Question 28D. Yanika opens a new credit card account with interest and fees as shown. Yanika makes a single purchase of $849 with the credit card. Part 1. Show that the balance owing on the credit card 24 days after making the purchase is $855.87. So we need to work out the interest first of all. Note that it's flat rate interest, which means simple interest, which means the formula I equals PRN. So the balance owing is equal to the principal plus the interest, which is equal to the principal plus the principal times the interest rate per period times the number of periods. So this is the I equals PRN. This is the original amount, or the original purchase amount. Now the principal originally, or which is the purchase, is $849 plus the interest that's incurred, which is $849 multiplied by the interest rate per period. Now that's 12.3% per annum, but we need to convert that into an interest rate per day. So it's 12.3% per annum over 365 days, multiplied by the number of days after making the purchase. So putting that all together and entering in this expression in the calculator, let's see what we get. Plus 849 multiplied by 12.3% over 365 multiplied by 24. And we get $855.8664. Okay, and rounding this amount to the nearest cent, we get $855.87 as required. Okay, so we've proven it. We've proven that we can show how we can get $855.87. Part 2. Inika makes her first repayment 24 days after making the purchase. She makes a cash payment of $450. What is the balance owing on the credit card immediately after her repayment is made and the repayment fee has been charged? So if you go back to the interest and fees schedule, we have a $3 fee for repayments in cash, so we need to add that on, obviously, at the end here. So we have the balance owing, which is $855.87. She pays $450 of that balance, but then a $3 fee is added because it's paid in cash. Okay, so again, entering in that expression, we have $855.87 minus her repayment of $450, adding on $3 as a cash payment fee. And yes, the button, we have $408.87. So that's the balance owing. Question 28E. Sophie is driving at 70 kilometers per hour. She notices a branch on the road ahead and decides to apply the brakes. Her reaction time is 1.5 seconds. Her braking distance, d meters, is given by d equals 0.01 v squared, where v is the speed in kilometers per hour. What is Sophie's stopping distance to the nearest meter? Now the first thing here to note is that stopping distance is really the sum of reaction distance plus braking distance. So let's work out the reaction distance first. First of all, we need to convert her speed from kilometers per hour into meters per second. And a quick way to do that is to divide it by 3.6. Nice little shortcut to use. Okay, so dividing that by 3.6 gives us 19, in fact I could convert this into a mixed numeral, 19 and 4/9 meters per second. So her actual distance then, so reaction distance, is equal to her speed in meters per second multiplied by the number of seconds it takes for her to react, which is 1.5 seconds. And what we'll do here, okay, so I've got the previous answer, I'm just going to multiply that by 1.5, and we get 29 1/6 of a meter. Now let's work out the braking distance. and we need to use the formula. Okay, so D is equal to 0.01 v squared. V is her speed in kilometers per hour. Okay, and just entering in that to the calculator. So 0.01 multiplied by 70 squared, and we get 49 meters. So the stopping distance is a combination, or the sum of 1 and 2. The answers 1 and answer number 2 together. So stopping distance is equal to 29 1/6 plus 49, adding those together. So you get 78.166. Okay. But we need to answer to the nearest meter. So we've definitely specified more than enough decimal places there. So that's just going to be 78 meters, correct to the nearest meter. Question 29A. The time in Brisbane is 4.5 hours ahead of the time in New Delhi. John flew from New Delhi to Brisbane via Singapore. His plane left New Delhi at 11:30 a.m. New Delhi time, stopped for 3 hours in Singapore, and arrived in Brisbane at 9 a.m. the following day, Brisbane time. What was the plane's total flying time? Now, comparing two different time zones, it's actually quite difficult. So we need to convert either the New Delhi time into Brisbane time or Brisbane time into New Delhi time. So I think it's easier to do what I said earlier, which is to convert New Delhi time into Brisbane time. So the plane left New Delhi at 11:30 a.m. and we're going to add on 4 hours and 30 minutes, which is, okay, so adding 4 hours, so we got 12:30 p.m, 1:30 p.m, 2:30 p.m, 3:30 p.m, add on another 30 minutes, that's 4 p.m. Brisbane time. And it's going to land at Brisbane at 9 a.m. the following day. And that includes a 3-hour stopover time. So what we're going to do is we're going to draw a number line to help visualize what's going on here. Now that everything is in Brisbane time, so this 11:30 a.m. is now 4 p.m. and instead of New Delhi time, it's now Brisbane time. So starting off from New Delhi, so I'll put ND here, that's New Delhi. Okay, this is midnight, so that's 12 a.m. Okay, so from 4 p.m, 12 a.m, it's going to land at 9 a.m. the following day, arriving in Brisbane. So how many hours have elapsed? So from 4 p.m. to 12 a.m, we have 8 hours. So there's 8 hours there. Then from 12 a.m. to 9 a.m. the next day, there's another 9 hours. Okay, so the total flying time is equal to 8 hours from 4 p.m. to 12 a.m. plus 9 hours, 12 a.m. to 9 a.m. But then we need to subtract this, stopped for 3 hours in Singapore. Okay, this is to get all 3 marks. Okay, so that's equal to 17 minus 3. So total flying time is 14 hours. Question 29C. When people walk in snow, the depth, d centimeters, of each footprint depends on both the area, a square centimeters, of the shoe sole and the weight of the person. The graph shows the relationship between the area of the shoe sole and the depth of the footprint in snow for a group of people of the same weight. So part 1. The graph is a hyperbola because D is inversely proportional to A. The point P lies on the hyperbola. Find the equation relating D and A. So it's inversely proportional, which means the formula is going to be D is equal to K over A. So dependent variable, independent variable. So A is the independent variable, which is on the x-axis. Now we need to use point P to determine the value of K. So substituting in this point, this coordinate, this is 300 on the x-axis, and when the area is 300, the depth is 15. So 15 is equal to K over 300. Multiplying both sides by 300, we have K is equal to 15 multiplied by 300. And we get 4,500. Therefore, the equation is D is equal to 4,500 over A. Part 2. A man from this group walks in snow and the depth of his footprint is 4 centimeters. Use your equation from part 1 to calculate the area of his shoe sole. So we're going to use this equation here, and we're going to solve then for A. So depth is 4 centimeters is equal to 4,500 over A. Let's multiply both sides by A. So we can do this in 2 steps so you can see how to solve this. 4 times A is equal to 4,500. Then we can divide both sides by 4 to make A the subject of the formula. It's just easier to write it in division, using division notation instead of fraction notation. And dividing one by the other now. So 4,500, which is our value of K, divided by 4, we get 1,125 square centimeters as the area of his shoe sole. Question 29E. Andrew borrowed $20,000 to be repaid in equal monthly repayments of $243 over 10 years. Having made this monthly repayment for 4 years, he increased his monthly repayment to $281. As a result, Andrew paid off the loan 1 year earlier. How much less did he repay altogether by making this change? So let's see how much Andrew would have paid off if he just kept his repayments at $243. So the original, the payment plan. So $243, it's per month, multiplied by 12 over 10 years, and that gives us, so let's take it out of stat mode, 243 multiplied by 12 multiplied by 10, and we get 29,160. So that's how much he would have paid back. Now, the new payment plan, he paid 4 years at $243 a month. But then he paid another 5 years worth of repayments at $281 a month. And we're told that why is it 5 years? Is because he paid off the loan 1 year earlier. So he paid it off over 9 years instead of 10. So we're going to add on $281 times 12 because it's 12 months in a year, because it's 12 payments, multiplied by 5, and that gives us, so 243 multiplied by 12 multiplied by 4 plus 281 multiplied by 12 multiplied by 5, and we get 28,524. So the saving is equal to 29,160, okay, that number there, minus 28,524. So he saves all up 29160 minus 28524, and he saves $636. Question 30A. A cylindrical water tank has a radius of 9 meters and a capacity of 1.26 megaliters. What is the height of the water tank? Give your answer in meters, correct to 2 decimal places. Now, the first thing we need to look at is the capacity of the tank. The dimensions of the tank are also important. The dimensions of the tank are in meters, which means that the volume of the tank will be in cubic meters. So we need to think about the relationship between capacity and volume. So the first thing we do is let's convert the megaliters into kiloliters, okay? And I might just put here that 1 kiloliter is equal to 1 cubic meter, and also that 1 megaliter is equal to 1,000 kiloliters. So let's start our solution off that way. So 1.26 megaliters. To convert megaliters into kiloliters, you're going from a large unit to a small unit. Let's multiply that by 1,000. And that's equal to 1,260 kiloliters, which is also equal to 1,260 cubic meters. That's why kiloliters is such an important unit of measure of capacity, because 1 kiloliter is 1 cubic meter. 1,260 kiloliters is 1,260 cubic meters. Moving on. Volume of a cylinder is equal to area of the base, pi times r squared times height. Now, we know what the volume of this cylinder is. 1,260 cubic meters is equal to pi multiplied by the radius squared. Well, the radius is given here, so we don't have to divide it by 2 or anything. So 9 squared multiplied by the height. Now we can make h the subject of the formula. So 1,260 divided by pi divided by 9 squared is equal to h. And I could do this because everything's just being multiplied together. There's no additions or subtractions. So let's enter this into our calculator and round the answer correctly, and we are done. $4.95 1,487, and rounding it correctly, it's going to be 4.95 meters, correct to 2 decimal places. Question 30B. Last year, Luke's taxable income was $87,000 and the tax payable on this income was $19,822. This year, Luke's taxable income has increased by $16,800. So part 1, use the table to calculate the tax payable by Luke this year. So increasing his taxable income by $16,800 will push Luke from this tax bracket here, $37,001 to $87,000, to this tax bracket. So first thing we need to work out is his taxable income. Okay, is equal to 87,000 plus the increase that he received, which is $16,800, Okay, adding those together, plus 16,800, and we get $103,000, $103,800. So, referencing this row here, $87,001 to $180,000, let's calculate the tax payable is equal to 19,822 plus, now when it says 37 cents for each dollar, that means 37%, multiplied by each dollar over $87,000. In fact, here's exactly $16,800 over $87,000. So that makes the calculation very easy. So let's just enter that in the calculator and see what we get. So 19,822 plus 37% multiplied by $16,800, and we get $26,038. So how much extra money, this is part 2, how much extra money will Luke have this year after paying tax as a result of the increase in his taxable income? Ignore the Medicare levy. So let's work out then what his net income is before his salary increase. Okay. Right. Is his taxable income minus the tax that he paid. Okay. So $87,000 minus 19,822. Oops. And we get 67,178. So let's work out now the net income after salary increase. Okay, is, and 103 minus the tax that he would have had to have paid, and that's equal to 103, 800 minus 26,038, and we get 77762. Okay, so the extra money that Luke will get is equal to the larger net income minus the smaller net income. Okay, so 77762 minus 67178, and we get 10,584. And that's the extra money that Luke will get. Question 30C. The diagram shows two triangles. Triangle ABC is right angled. This is triangle here. With AB equals 13 centimeters and angle ABC equals 62 degrees. In triangle ACD, so that's this triangle here, AD equals X centimeters and angle DAC equals 40 degrees. The area of triangle ACD is 30 square centimeters. What is the value of X correct to one decimal place? So in order to be able to find X, okay, we have the area of this triangle ACD. We also have a known angle. So there's two pieces of information here. We need a third piece of information on this triangle ACD in order to be able to find side X. Now, given that we're working with the area of a triangle, that implies we need to use the sine rule for the area of a triangle. That's the half AB sine C. and then we're going to rearrange the formula to then find the value of x. But before we can do that though, we need this side AC here. This side CD, we can't do anything with that. Okay, so AC, however, can be found using this right angle triangle. Let's call this side Y. Let's call this our angle theta, and we can use our sine, cos, and tan ratios to be able to work out Y, and then we can use that to then work out X. Okay, so that's the logic. So let's work out Y first. Y is the opposite side to theta. We have a hypotenuse. That's our opposite side, which means we're going to use the sine ratio. So sine of 62 degrees is equal to Y over 13. Rearranging this formula to make Y the subject, we multiply the sine 62 by 13. Y is equal to 13 multiplied by sine 62 degrees. And if you like, we can evaluate that. Okay, so 13 multiplied by sine of 62 degrees. And I'm going to write the entire decimal. I'm not going to round this yet. Okay, so in order to maintain some level of accuracy as we work this out. So 11.47831871. So that's our sort of our first stage, or our first major step, is to work out this value of Y. Now let's use triangle ACD to work out this side here, this unknown side X there. Okay, so in triangle ACD, so this is where we're working now. Okay, area is equal to half multiplied by A multiplied by B multiplied by sine of C. Sometimes I like to start off with the formula, because that way I know what I need to do. And if I need to rework this formula or rearrange it somehow to make one of these variables the subject of the formula, we can do that. Let's substitute in some known values. We have the area of the triangle, that's 30, equal to half, multiplied by, now we have a value Y, we just found that, so that's going to be 11.47831871 multiplied by X, that's our side B, multiplied by sine of 40. Okay, so it looks like a bit of a mess, but it's actually not as bad as all that. Let's rearrange this, make X the subject of the formula. Now, because these are all multiplied together, all we need to do is this. Starting off with the 30, we're going to divide it by half. We're going to divide it by this number here, 11.47831871, and then we're going to divide it by sine of 40. Everything's just divided. Why? Because it's the opposite of multiplication, the inverse operation. And that's equal to X. Therefore, X equals, I'm going to enter all that into the calculator. Okay, so 30 divided by half divided by 11.47831871. Do not rush this. Divided by sine of 40. And we get 8.13215 ... We don't need that many decimal places because we're practically at the final answer now. That's centimeters. We need to round it though to 1 decimal place. And so that's equal to 8.1 centimeters, correct to 1 decimal place. Question 30D. A game consists of 2 tokens being drawn at random from a barrel containing 20 tokens. There are 17 tokens labelled 10 cents and 3 tokens labelled $2. The player wins the total value of the 2 tokens drawn. So part 1, complete the probability tree by writing the missing probabilities in the boxes. So from the start, the first token drawn, we have 17 10-cent pieces out of 20. That leaves 3 tokens left that are the $2 coins, or the $2 tokens, should I say. Now that we've drawn a token from the box, we now have 19 tokens left. So in fact, all of these probabilities in the second draw, or drawing the second token, will all be over a denominator of 19. So we can fill that out immediately, in fact, like so. But we need to work out the numerators though. If there are 16 10-cent tokens in the box, the sum must equal 19. There must be 3 $2 tokens in the box. So when you add the numerators, 16 plus 3 should equal the denominator of 19. Okay, what about these two here? So if we've drawn a $2 token, that means that we still have 17 10-cent tokens in the box. After all, we start off with 17 10-cent tokens, and on the first draw, if we draw a $2 token, we still have 17 10-cent tokens left. But there's now one less $2 token. Okay, so remember that we initially start off with 3 tokens labeled $2. That means we have 2 tokens left. So that answers part 1. Now part 2, technically, it's actually not in the syllabus anymore. It's actually a question from a previous syllabus. But I still think that it's worth going through this, and I've just added a little bit more to this. So part 2, considering that the game costs $1 to play, calculate the financial expectation of the game. So what this means is that how much on average would a player stand to win or lose. So we take into account how much it actually costs to play. So how much a player will win or lose on average based on these probabilities. So I still think it's a question that's well worth going through. So the way we work this out is we work out the probability, for example, of winning 20 cents, and we then multiply it by the value of that win. So I might just update this probability tree because I think this is going to help us definitely answer part 2. So winning 20 cents, I'm just going to write all of these in dollars. Winning $2.10, winning $2.10, winning $4. So I'm going to just express everything in dollar terms. The next thing we need to do is to work out the probability of each of these outcomes. Okay, and we can in fact just update this diagram here, this probability tree. The way we do that is we multiply along the arms of the tree or the branches of this tree. So winning 10 cents and 10 cents, it's going to be 17 on 20. So you multiply the probabilities along the branches. Multiplied by 16 on 19, and we get 68 on 95. So that's the probability of winning 20 cents. So you can see it's actually quite high already. So what about winning $2.10? So 17 on 20, chance of winning 10 cents. And the second token being a $2 coin is going to be 3 over 19. And we get 51 on 380. We're going to use these probabilities to help answer part 2. Now, winning $2.10 again. Okay, so we have a 3 on 20 chance of getting the first token worth $2 multiplied by the second token, or the probability of the second token being 10 cents, which is 17 over 19. And we get 51 on 380. And lastly, to win $4, the probability of that is 3 over 20 multiplied by the probability of the second token being $2, which is 2 over 19. And we get 3 on 190. Okay. So the financial expectation, okay, I would say or we could say the average win or loss is equal to the probability of winning 20 cents. So that's going to be 68 over 95 multiplied by 20 cents plus the probability of winning $2.10. In fact, winning $2.10, we don't have to do this 2 separate times. We can just work out one of them and then just double it. So it's going to be probability of winning $2.10, or one lot of $2.10. So it's 51 over 380 multiplied by $2.10 multiplied by 2. Okay, because we have 2 lots there. And the last outcome, which is the win of $4. Okay, and that's a 3 on 90 chance. So plus 190 multiplied by $4. But we need to subtract the cost of playing this game. It costs $1 to play. So working all that out now. Okay, so 68 on 95 multiplied by 20 cents plus 51 on 380 multiplied by $2.10 multiplied by 2, because there's two of these outcomes, if you recall, plus 3 on 190, okay, multiplied by $4, okay, and then minus $1 to play. And we end up with negative 23 cents. Okay, in fact, I'll just do it this way. Okay, all right, just write it like that. Okay, so this represents an average loss of 23 cents per play. And that's the financial expectation of this game. Question 16. The scale diagram shows the aerial view of a block of land bounded on one side by a road. The length of the block AB is known to be 45 meters. Calculate the approximate area of the block of land using 3 applications of the trapezoidal rule. First thing to note is that the diagram here is to scale. Second thing to note is that AB is 45 meters. So let's work out the scale first. And we find that the approximate measurement of AB is around 45 millimeters. Okay, so 45 millimeters on the diagram is equal to 45 meters in reality. Okay, so the scale is 1 millimeter is equal to 1 meter. Okay, so if this is 45 equal length segments there, these will be 15 meters each. So for the trapezoidal rule, we need to measure all of these parallels. So let's do that. And just with a ruler, just approximate it. So that's around 25 millimeters. So this will be 25 meters. This one here is around 20 millimeters. So this means that according to our scale, this is 20 meters. This one here is 25 millimeters again. So according to our scale, that's 25 meters. And last one, this is around 30 millimeters. So that makes it 30 meters. So now we need to apply the trapezoidal rule 3 times. So the area of this shape is equal to 1/2 times the height of the trapezium. So we are forming basically trapeziums there. So first trapezium, 1/2 times 15 multiplied by the sum of the parallels. So 25 plus 20 plus the second trapezium, 1/2 times 15 multiplied by the sum of its parallels, 20 plus 25, plus 1/2 times 15 times the sum of the parallels of this third trapezium, which is 25 plus 30. entering in all of that to the calculator. So now 1/2, I'm just going to put 0.5 times 15 times 25 plus 20, that's 45. Just so you don't make a mistake, maybe we'll just enter it in as we've written it. Okay, so under exam pressure, sometimes we could make some silly mistakes and errors that you normally would not make. 20 plus 25 there, 20 plus 25, plus last one, 0.5 multiplied by 15 multiplied by 25 plus 30. And we get 1087.5. Square meters. Question 18. The diagram shows three towns, X, Y, and Z. Town Z is due east of town X. The bearing of town Y from town X is north 39 degrees east, and the bearing of town Z from town Y is south 51 degrees east. The distance between town X and town Y is 1,330 kilometers. A plane flies between the three towns. So part A, mark the given information on the diagram and explain why angle XYZ is 90 degrees. So the first thing is town X and town Y, the distance is 1,330. So I'm just going to write that in first. Now, we have two bearings to mark in. The bearing of town Y from town X. So from town X means I'm going to draw a north-south line, a north-south axis. Okay, I'm going to call this north 1, and it's north 39 degrees east. So from north, we're going to mark in the angle 39 degrees in an easterly direction. And the bearing of town Z from town Y. So there's town Z. So from town Y, okay, I'm just going to draw in another north-south axis. I'm going to call this north 2. Okay, and I'm going to call this south 2. This one is south 1. If we'll need it, we'll use it if necessary. So this just marks in these two axes, they're parallel to each other. And we need to also mark in 51 degrees, okay? So that's that compass bearing there. So that one's 51 degrees. So mark the given information, which we've just done, on the diagram and explain why angle XYZ is 90 degrees. So this is XYZ. Now we can see here that the axis, this N1, S1, this line, is parallel to N2, S2. That means that this angle here, N1, XY, is alternate to this angle, X, Y, S2. So this one's going to be 39 degrees. So we'll write that in. So angle N1, XY is equal to angle XYS2, which equals 39 degrees. And we need to say alternate angles on parallel lines. Okay. N1, S1 parallel with N2, S2. You could write anything to that effect. I've just used some terminology there and some symbolism, but anything that states alternate angles and states that N1, S1 and N2, S2 are parallel to each other and that XY is a transversal even would work. So anything along those lines is fine. Now, angle XYZ is equal to angle XYS2 plus angle S2YZ, okay, which equals 39 degrees plus 51 degrees, which equals to 90 degrees as required. Okay, so this is the 90-degree angle. Part B. If the speed of the plane is 570 kilometers per hour, how long does the flight take from town X to town Y in hours and minutes? So we can use our speed, distance, time triangle. Okay, so distance is equal to speed multiplied by time. And we want the time. So time is equal to distance divided by speed. So time is equal to the distance, which is 1,330 kilometers, divided by the speed of the plane, which is 570 kilometers per hour. Okay. Multiplied by 570, and we get 7 on 3, or 2 hours and 20 minutes. Part C. Find the distance between town X and town Z to the nearest kilometre. Okay, so there's town X. Okay, town X to town Z to the nearest kilometre. Now we have a right angle triangle here, and we can use whatever angles we like, really. I mean, it's probably the most convenient to use this angle here as our theta. Okay, so we don't even need the sine rule or the cosine rule at this point. Okay, so there's our theta. We have 1,330 as one of the short sides. We actually want to find the hypotenuse, so we can't use Pythagoras theorem because we don't know what YZ is. Okay, but our theta here, this is going to be 51 degrees. Okay, so I'm just going to put the working out just somewhere here. So our theta, okay, which is equal to angle YXZ, which is equal to 51 degrees. Since 39 degrees plus 51 degrees is, well, they've got to be complementary, they've got to equal 90 degrees from north to east. Okay, and we need, actually I'll go back to the diagram, we need XZ. There's our theta. This is an adjacent side. In fact, if I turn the paper around this way, okay, just let it refocus. Yep. So you can see that's an adjacent side. Okay. We want the hypotenuse, and our theta is 51 degrees. So we're going to use cosine. Okay. So cos of 51 degrees is equal to 1,330 over XZ. So as a bit of a shortcut, okay, if you want to make XZ the subject of the formula, or you take the 1,330 and you place it on top of the cos 51. It's just a much faster way of doing this. So it's going to be 1,330 over cos of 51 degrees. Moving on, and it says to the nearest kilometre, so 1,330 over cos of 51 degrees, and we get 2,113 kilometres, 2113. Okay, and that's correct to the nearest kilometre. So I might just mark this in here, might come in useful later. Okay, and we actually have a part D as well, so I might just put that there. okay, because the diagram is going to be useful. So part D, the plane is going to fly from town Y to town X, stopping at town Z on the way, leaving town Y. The pilot incorrectly sets the bearing of town Z to south 50 degrees east. The pilot flies for 1,650 kilometers before realizing the mistake, then changes course and flies directly to town X without going to town Z. There's quite a bit going on here. From where the pilot changes course, is it a shorter or longer distance to town X than if the plane had flown from town Z to town X? Let's have a look and see how we can work this out on the diagram. Just quickly, plane's here, okay? So originally it was meant to fly to town Z, so that's south 51 degrees east, this way. But the pilot accidentally puts in into the computer south 50 degrees east. So it's actually going to end up somewhere here, the plane, potentially. So I'm going to draw this just faintly in pencil. Okay, so just to make it a little bit easier to see. Okay, so just something like that. So that's what the plane's doing. So starting at Y, it's ending up kind of not quite at Z, but more sort of west of Z potentially, and it flies for 1,650 kilometers, and then from here. Okay, the plane is then going to fly to town X. So the question really is asking, is the distance XZ greater or less than this distance here, X, and to this sort of where it turns? Okay, so where it changes course, is that a shorter or longer distance? So if we've gone 1 degree back to the west, instead of a 90-degree angle, it's now going to be just going to mark it in faintly here, it's going to be an 89-degree angle. Because it's originally 90, but the plane's come back 1 degree. So that's 89. Now we have 1,650, that's one side. We have 1,330. We want this side here. This is this distance. I'll just draw it faintly there as well. All right. So we want this distance here, 2 known sides, and an included angle. Cosine rule. Okay, so as soon as you hear that, 2 sides and an included angle, you know it's going to be the cosine rule. So by the cosine rule. Okay. Let's give this another letter. Let's call this W. Actually, no, we'll call it a different letter. Let's call it, let's just call it A. So we haven't used the letter A yet. W could be misconstrued for west. So let's call it A. Okay. So AX squared is equal to, what are the 2 sides? 1,330 squared. Okay. Plus 1,650 squared minus 2 times 1,330 multiplied by 1,650 multiplied by cos of 89 degrees. Okay, so AX squared is equal to plus okay, and we get this big number there, so I'll just write that down, 4414801.388. Now AX is equal to the square root of this number, 4414801.388. Okay, so it's good to show what you're working out, and we can just sort of just do square root of the last answer, which is 2101.14. Okay, so we're comparing that against this distance here, 2, 1, 1, 3. Now, 2, 1, 1 is less than 2, 1, 1, 3. Okay, so therefore it is a shorter distance than XZ. Question 19. A project requires activities A to G to be completed as shown in the table. The minimum completion time for the project is 50 days and the critical path includes the activities B, D, E and F. The float for G is 3 days and the float for C is 8 days. Find a possible duration for each of the activities A, C, F and G. So that's activities here with the question marks. Include a network diagram in your answer. Okay, so let's start. Let's have a look at the table first. So before we worry about durations, okay, we can draw the network diagram immediately. Activity A and activity B do not have prerequisites, so they're the ones in the beginning. You can do this in pencil, and you can just do it in just lightly in pencil. Okay. If you make a mistake, then it becomes easy to just rub it out and draw it correctly. Okay. We start and end each activity with a vertex. All right. Just note that the edges represent the activities, not the vertices. The vertices just represent the start and end of each of the activities. Okay. Now we can fill in the duration as well. Duration of A, okay, is question mark. Duration of B is 15 days. Okay. Let's have a look now at activity C. Activity C depends on A. So we can just draw activity C that way. And activity C, we don't know what the duration is, so we'll just put a question mark there. We'll deal with that later on. Activity D depends on A and B. So we need A and B to be completed first before we can progress to activity D. So we're going to need a dummy activity. Okay, so there's our dummy activity. Then we can draw in activity D. And D has a duration of 20 days. Okay, I think we're happy with that. Let's have a look at activity E and F now. So activity E depends on D. So going back to the diagram, we can put activity E really anywhere we want, as long as it's after D. But just go one more row. Activity F depends on both C and E. Okay, so in other words, C and activity E have to come together in the end. I have to draw them together at a vertex. So what I'm going to do is I'm going to draw E after activity D, but then joining on to C so that I can draw activity F. So back up this way. Okay. And that's activity E. Okay. And activity E is 8 days. Now we can draw the last two activities. So we've got activity F, depends on C and E, and that's it. Then we've got activity G, depends on D. Okay. And that's the end. Okay. So activity F can be drawn from activities C and E, where they're joined together at this common vertex there. Okay. So this is activity F, and there's a question mark on that. And activity G is drawn from activity D. And there's a question mark there in terms of its duration. So there's our end or project end, and there's our project start. Okay, moving on. Now we need to work out these durations. And what I'm going to do is I'm going to draw these dominoes. Okay, so I'll draw a set of these. Okay, these are the EST, LST. Dominoes there. Okay, basically just next to each of the vertices. And one for the start. Okay, let's now mark in the critical path. So if you're happy with that diagram, you can trace over it in pen, just because you're meant to be using black pen, of course, for answering these questions. Okay, but if you're happy with this diagram, okay, we can now trace in the, or just highlight, I guess, the critical path. So the critical path is B, D, E, and F. Okay, so B, D, E, and F. Now, we do know the minimum completion time for the project is 50 days. So that means the last domino, we can put 50-50, okay? And the starting domino is going to be 0, 0. Okay, the earliest start time and latest start time. And we know that B is on the critical path, and B has a duration of 15. So this one is going to be 15 and 15. Anything on the critical path will have an earlier start time and the later start time being identical. So that'll be 15, 15. D is also on the critical path. It has a duration of 20, so we add it to 15 and we end up with 35. Now, E is on the critical path. We add that to 35 and we get 43. So the EST and the LST for F is going to be at the 43 day mark. Now that means then that we can calculate the activity time for F. F will have no float because it's on the critical path. So duration of F is equal to 50 minus 43, which is equal to 7 days. So we've worked out one. We can also work out G. G has float, or it has float time, and it has a float time of 3 days. So G could start at the 35 day mark, ending at the 50 day mark. G has a float of 3 days. That means that the activity time of G, or the duration of G, has to be 12. So duration of G is equal to 50, that's the LST, minus the float time of G, which is 3, minus 35. And that's going to equal 12. So we now have two durations worked out, and that leaves us now to activities A and C. Now, A and C are not on the critical path. We do know the float for C is 8 days. A has no prerequisites. So what I'm going to do now is I'm going to replace the question mark now with a pronumeral to make this a little bit easier to understand. So let's say the duration of A is X days. That means that the earliest start time of activity C must be X. Okay, so if the duration of A was 10, 10 would go up here. We know that the float for C is 8 days. So what I'm going to do now is I'm going to replace the question mark for C, which represents the duration of C, with the pronumeral Y. Now, since the float time for C is 8 days, the duration of A and C must equal to 43 minus the float time of C. Okay, so in other words, duration of A plus C is going to equal to 43 minus the float time for C, which is 8 days, which is equal to 35. So that means whatever X is and whatever Y is must add up to 35. So therefore, X plus Y must equal 35 days. So that means that we can choose whatever values we want for X and for Y. So we could use, for example, okay, so since X plus Y, so that's the activity time of A, activity time of C must equal 35. One solution for A and C is, I don't know, 2 days and 33 days respectively. Okay. So I could put 2 here and I could put 33 here. You could use 1 and 34, 3 and 32. As long as these two numbers add up to 35 days, it's a valid or a viable answer.